Hi, how's it going? Let me know how the video is. I had a few issues setting up OBS, but anyway, what I'm going to do in this video is basically set the scene up to have a custom render pass and a custom frame buffer and do a bit of post-processing. Really nothing too crazy, just make it black and white. So just to see where we are at this point in time, we'll run everything and we have our mouse. There we have it. So what I want to do is put all of this in black and white. So, I'll just get this set up. So what I'll do is I'll go and create a new file. That will be a Swift file, and I'll call it frame buffer. Actually, change my mind. I'll call it Renderpass. There we go. Okay, so the first thing we'll do is just import metal kit. There we go. So now our render pass is going to basically describe the attachments which we want to output to. And there'll be two. There'll be a color buffer and a depth buffer. Now you might be saying, well, Andrew, at this point you've declared a color buffer, that's a texture where the pixels will be written to. Shouldn't we be declaring a texture for the depth stencil buffer? And yes, we absolutely should, but the way I'm doing this, I'm trying to recreate an error to show how to do debugging and stuff. So you're 100% correct, we'll get to that. So the way this is going to work is we'll have our custom render pass, and that will be a full 3D situation. We'll render the whole scene to that in color. And then we will bind the default render pass and run it again. And in that default render pass, we will be rendering down to a black and white texture. But anyway, let's go to the constructor for the render pass. Okay, so at this point we've got our color buffer, and what I'm going to do is I'm just going to go over to the material lump and grab all of that stuff, because we're really going to be doing that again. As a matter of fact, we can grab this bit as well. Okay, so this is just configuring the texture, which will be acting as our color buffer. So for the texture type, of course, it will be a two-dimensional texture. For the pixel format, well, we can cheat a little bit and say, well, we know from the rest of our program that it's this one here. Oh, we should probably be changing all of this. Okay, for the width and height, it really doesn't matter, because what we're going to do is render to the color buffer and then sample from that color buffer again when we draw it on the screen. So it actually doesn't matter at all, but I'm just going to take in the numbers that I'm given. I mean, yeah, it does matter. Make it bigger than 1 pixel. Okay, done. All right, so for the sample count, that's 1. Array length will just be 1 because it's one single image. Allow GPU to optimize contents. Let's just say no, it doesn't really matter. And then for the usage, now this is a little bit weird, because what I want to do is I want to have two things. I want to have render target as well as shader read, because, well, we're going to render to it and then we're going to read it from a shader, but Swift just doesn't like that. So what we can do instead is define this. We'll go color buffer. Let's shortcut that and not even store it in a variable. We can have a constructor, and the constructor for the texture usage can take a sequence of options. And that's sort of the Swift equivalent of piping these together. There we go. Okay. Cool. So we've got the color buffer. Now, the next thing we need, of course, is we need to make the color buffer sampler and then the depth state. So we'll just go over again to the material lump because, again, here we're configuring a sampler. And all of this is fine, I reckon. I guess the only thing I'll change is the max anisotropy. I don't think we're doing any anisotropic filtering, so just set that to 1. Again, I don't think it really matters. Maybe it does, who knows. But then we'll construct the color buffer sampler. Excellent. Now we just need to construct the depth stencil state. And to do that, we can go to our renderer and grab the bit where they describe it. Here we go. So we're creating a depth stencil state from a descriptor. And we can actually grab all of this because our engine is not going to use its own depth test, because all it's doing with its default frame buffer is just blitting onto the screen. So we don't need a depth test for that. So we can, in fact, get rid of, if I can find it. Here we go. And several errors will then appear, and that's fine. I'll address those later. It's actually a good point. It actually does a good job of highlighting where the... Anyway, I'm talking too much. Right, so it just doesn't understand metal device. We'll just say device. Maybe it was a subtle misspell. Yes, it is, because what's a depth stencil? Okay. Right. Okay, excellent. So these are the attachments. And again, intentional errors in this, because I want to go back to debugging later. These are the attachments that the Renderpass will use. Now, the next step is I need to describe the Renderpass, because if we go back to the renderer, let's close that one down. That's fine. Okay, draw. So this is the first thing they do is, yeah, so this is actually constructing the Renderpass on the fly in the draw function. And I don't want to do that, but I do want to do something like that. So I'll just grab all of that. Paste that in there. Now we're going to have some sort of Renderpass descriptor. And what we essentially need to do is populate the fields of this Renderpass descriptor so that later on our renderer can grab that and use it to create the appropriate Renderpass. So we don't need that. View, we don't know what that is. So this is a little bit funky. Maybe I should change that to... There we go. Oh, come on, come on. Oh, we haven't even constructed it. Okay, so we construct one of those. And then I think we can set that back to a let. Hey, do you like this sort of fly by the seat of your pants coding style? I'm having fun. Okay, so there's a little bit of a funky thing with this Renderpass descriptor, because if we look at this, we look at the fields, there's this color attachments, which is, yeah, like it says, an array of state information. So what we'd want to do is set this to some array. Whoops. But we will come into an error here because it says that the color attachments is a get-only property, which is super weird. I mean, how would we specify how many color attachments? I don't know. That's a weird question. That's a weird question. So I have to sort of treat it as if it's pre-populated in a sensible way. Luckily it is, I think. So what I'm going to do is I'm going to set the texture of the first attachment to my color buffer. And that will set it up so that it's rendering to that color buffer. And now we're also going to need to modify the depth attachment. So we go Renderpass descriptor. And of course, you can only have a single depth attachment. It would be a little weird to have more than one. And like I said, I'm just going to set this in an incomplete way. Spoiler alert. So yeah, let's pretend that that has properly set up our Renderpass descriptor. Now, we'll just go back to the renderer and describe how this goes. So so we get the command buffer. We get the command buffer and then we construct. Oh, I'm all over the place. We need to first of all initialize one of these things. So I'll just say, alrighty, we'll go. Just declare one of those, and then in the initializer, we will create it. So go down to our, whoops, oh, there we go. Right down the bottom. So pass in the metal device, and for the width, just whatever the width of our screen is, but it really doesn't matter. I could pass in a larger size. It would just be downsampled perfectly fine. Okay, so we've got that. Now when we go to render, I want to use that descriptor. So I'll say, I'll make the render encoder, and I will take the custom render pass. Okay, cool. So we pass that in, we do our thing, and then we grab the info from the screen. So this is essentially saying grab the texture of the swap chain of the screen that we want to render to, and then I'll create a post-processing render encoder. And then I'll make another function where I go ahead and use that. But okay, so the draw function will be in here. And anything we draw here will go directly on the screen, whereas anything we draw here will go onto the custom texture. Okay, so I guess why not? I'll go and construct the shader for this stuff. So I'll just go down to my folder and we'll make a new file. That'll be a metal file. And I'll just call it post shaders. Okay, now just stick that in there. Now, when it comes to rendering to the screen, I mean, at the moment, we are using this. If we go to definitions, we've got this vertex struct, which has a lot of useful information. But I mean, really, when you're rendering to the screen, you just need the position on the screen. So I'll construct this simple vertex, and that will really just have a two-dimensional position. There we go. Okay, so then I'll just go to the post shaders and we will go ahead and use that. So we'll have this fragment unlit. I'll just change that to fragment post. And I think the rest of this is fine. Yep. And I'll just change all of this stuff. Okay, so really that's all we need. We don't need all this extra uniform stuff. So we're going to have our output. We'll grab the appropriate vertex and we'll set the position of the output. So what I'm doing is just taking that two-dimensional XY coordinate, just putting it out on the screen. What? Oh, I totally missed that. This should be an array of simple vertices. Okay. Excellent. All right. So if you look at a two-dimensional position on the screen, it'll be somewhere between -1 and 1. Now, if you think about it, you can also use that to generate your texture coordinate because, well, you're somewhere on the screen, right? So what I'm going to do is I'm going to take the position and then add 1 to everything. So then it goes from -1 to 1. It now goes from 0 to 2. And then to change that back to the appropriate range, we'll just halve the value, whatever it is. Now, yeah, I'll come back to this in a second when we see what it looks like on the screen. But now we have the fragment shader. Okay, so for the fragment shader, we'll take the input and we will have, I guess I'll change this to the screen texture. Actually, I'll be even, no, why not? I was going to call it color buffer. It really doesn't matter. Then for the sampler, I'll call this the screen sampler. And we don't need this other stuff, so we can just get that out of there. Okay, now for the base color. Oh, and there's one thing I almost missed. This is a texture 2D array originally. I'm going to set it to a texture 2D. Okay, so we sample with the screen sampler object based on the texture coordinates, and we don't need to put in the array number. There we go. And we don't need alpha at all. We can just leave that. Okay, so that's fine, but like I said, I'm going to convert this to black and white, so I'll just take the average of all components and just pass that in. Okay, cool. So now I need to create basically a quad mesh that I can put up on the screen. So I'll just go over and add a new file, which I'll call screen quad. And now I will go ahead and, what am I going to do? I'm going to do this one from scratch. Okay, excellent. So there we have it. We have 6 positions covering the 4 corners of the screen. That's a quad that's going to cover the screen. Excellent. So we'll just go back to our engine and instantiate one of those. I'll say, alrighty. And while I'm at it, I should probably go ahead and create the pipeline as well. So I'll have lit pipeline, unlit pipeline, and what am I thinking? Let's call this post pipeline. Okay, so we have that. And in addition to that, we'll have the screen quad. Okay, so I'll just go down to the pipeline stuff. Oh, where are we? Okay. There we have it. I should probably rename that, so I'll just go to the post shaders and we'll have vertex shader post. fragment shader post. And I'm just going to also create a different vertex descriptor. So if we go right up the top, where are we? So I will call this a simple vertex descriptor. Okay, so the simple vertex descriptor is really only going to have one thing. It's just going to have a format. It's just going to have position. So format is float2. The offset is 0, of course. And the buffer index is 0, no problem. And then we increase the offset by the SIMD2 size. Okay, no worries. And then we get rid of all this other stuff. We don't have texture coordinates, we don't have normals. And then we set the stride of that simple vertex descriptor. And then when we come to make the post shading pipeline, we pass in the simple vertex descriptor for that one. Okay, I think that's fine. I think that's fine. So then after we create the render pass, we'll go ahead and instantiate the screen quad. I think that's fine. Okay, so I'll just briefly step through what I've done at this point. So we've got this custom render pass, which has its own color buffer and depth buffer. More on that later. We then have a screen quad, which defines the points on the corners of the screen. So when we go to draw this, this will draw a quad over the whole screen, like its name suggests. What we then do is we take this really simple vertex format, which just has a vec2, and we construct a descriptor of that, and then we construct a post-processing pipeline, which is just set up to draw on the screen. That's all it does. We set up the custom render pass and the screen quad. Okay, excellent. So I'll just close that down, and then I'll step through the rest of the drawing logic. No, not close everything. Okay, so comes time to draw. So we pass this in and do the drawing stuff. Now, how does that work? Well, let's have a look at draw lit objects. We need to set the depth stencil state, and what we'll do is we'll set it so that we're rendering to our custom render pass. So we go custom render pass depth stencil state. That's the one that we read from. And then the rest of this should be fine. We just do the regular drawing stuff. Okay. Then for draw unlit objects, again, we'll go custom render pass depth stencil state. And then I'm just going to grab this to make another one. Let's do draw post. We'll get to that in a second. Okay, so I'll close that down. All right, so we're all set up. So we go ahead, we draw all this stuff, then we stop encoding with that render encoder. Then we go ahead and we use our command buffer to make another render encoder, which is called the post render encoder. And at that point, we now draw all the post stuff. So we'll go draw post based on the post render encoder. Okay, so the first thing we'll do is on that we will bind the post pipeline, and now we don't do any depth testing, so we don't need to. But what we will need is we'll need to set the fragment shaders texture, and we'll be reading off the texture which our custom render pass wrote to. So we'll say, okay, custom render pass color buffer, and that will be bound as texture unit 0. And then we'll also need to set the fragment And again, we'll use the custom Renderpasses color buffer sampler, index 0. And then finally, we'll need to set the vertex buffer. Okay, so we'll set it to the screen quads vertex buffer with an offset of 0. And again, we'll bind that to index 0. Okay, now we'll go ahead and draw. So we'll say, okay, render encoder. Yeah, draw primitives. The type will be triangle. We'll start at vertex 0. And I mean, we could read off from the screen quad, but this is, like, we know it's 6, so we'll just say 6. Okay, so we do all of that stuff, draw the screen, basically, and then we end encoding and just go ahead and present. And because this encoder was made with the command buffer, those commands are encoded to the command buffer. Okay, so fingers crossed, let's give this a go. Okay, so build succeeded. That's good. However, we're erroring out. And this can be really frustrating because it just says, yeah, I know the thread aborted. What? So big thank you to Copernicus on the Get Into Game Dev Discord for pointing this out. What you can do, I wasn't aware of this, but you can go down to product up here and then scheme and then edit scheme. And then right here in run, there's this diagnostics tab. And right down the bottom, we have validation options. So this is sort of how you can switch on validation layers in Metal. I think it was on anyway, but let me just run this again. Okay, so it is complaining. And then this is, again, this is super frustrating, super hard to work out. But down the bottom here, there's this little tab, and I can click that, and it will actually show me the validation errors. And some of this is just standard loading stuff, but let me try find this. Here we go, right down the bottom here. Okay, set render pipelines. Failed. Set render pipeline state validation for depth attachment. The render pipeline state pixel format must be something as no texture is set. So, again, I was hinting at this. I'm bad at hinting, but we need to set a texture for the depth buffer. We can't just say, do this. Like, it won't handle it for us. So no problem. We can totally fix this up. We'll just go to the render pass. And right up the top, see I had a color buffer. I'm also going to set up a depth buffer. And that will be a texture, just the same as the color buffer. And I'm actually going to grab all the stuff from the color buffer. Okay, right, so it's going to be a 2D texture. Its pixel format, will be, let's go 32-bit depth. Okay, I think this is all fine. Yeah, I think that's fine. That's fine. Okay, so we've made the depth buffer. Now what we'll need to do is just actually grab all of this. There we go. Okay, so the texture for the depth attachment is the depth buffer that we created before. When we load it, we're going to clear it off with a depth of 0. When we store it, we're going to store it. So I think that should be perfectly fine. Fingers crossed. Let's give this a go now. Okay, there we have it. So we are in fact in black and white. However, our world has turned upside down, and this really has to do with Metal's coordinate system. It's just not, sort of funky. Okay, so How can we fix that? Well, the easiest way to fix it is simply to do our thing, and then after setting this, flip the y coordinate. So we'll go text coordinate, y component, multiply it by -1. And that should be it. There we go. Excellent. So there we have it. Everything is in 2D, in black and white, just like in the 1930s Mickey Mouse Adventures of the Mouse. Okay, perfect. So yeah, very cool. But hopefully you can appreciate that along the way we have created a render buffer, which is a very, very cool thing. Anyway, hope you had fun, and I will see you again soon. All right, have a good one. Bye.